These paradoxes keep scientists awake at night with no solutions. That is the title of the video we are reacting to today. This is done by the Destiny YouTube channel. Thought this would be a fun one. We had done a video not too long ago about paradoxes, so I thought we'd get a little deeper into it.
How do we feel about no solutions?
Totally fine.
How do we really feel? How
Yeah.
do we really feel about no solutions? I think that there's gold there. Let's watch it.
The human brain is one of the smartest on the planet, but there are some things we just can't wrap our minds around. One of those is the paradox. We've evolved to think of reality in a specific way, but there are paradoxes out there that suggest reality doesn't work the way we think it does. And now, some physicists think they've solved a 50-year-old paradox. But have they? And what are the other strangest paradoxes? Get ready to find out. A lot of you are probably familiar with the Fermi Paradox. Named after Italian physicist Enrico Fermi, who is famous for creating the first nuclear reactor, this paradox seeks to answer the question, where are the aliens? Given that our star and Earth are part of a fairly young planetary system compared to the rest of the universe, and that it's possible for a civilization to achieve interstellar travel during this time, it seems we should have been visited by some form of extraterrestrial intelligence by now. Now, some say it's not a real paradox, because we can only guess that there is intelligent life out there. But the Drake equation is used in this so-called paradox to estimate the number of possible civilizations in our galaxy. The Drake equation uses 7 variables to estimate the number of detectable civilizations in the Milky Way. This gave us an idea that there could be millions of Earth-like worlds with civilizations out there. But this was back in 1961, and no one knew of any worlds orbiting stars other than our own. It was only recently that we got a good idea. In 2020, astronomers using data from the Kepler Space Telescope found there are more than 300 million worlds with similar conditions to Earth scattered throughout the Milky Way. The analysis concluded that roughly half of the galaxy's sun-like stars host rocky planets in habitable zones where liquid water could be on the surface. In fact, planets are extremely common and outnumber all the stars in our galaxy. And very soon, the James Webb Space Telescope will be headed into space to look for new potentially habitable worlds. We'll have a new video on that soon, so make sure to stay tuned here.
That one kind of makes me feel sad, the idea that, with all the possibilities out there, the aliens, we could be totally alone out there. But I was just thinking, like, if the Big Bang's true and everything kind of started at the same time, well, then maybe evolution demands that if they say there's 300 billion or however many civilizations out there, we're all roughly around in the same place. That's why we haven't been able to visit each other. Maybe someone would have to come from another galaxy, and that's why it takes longer than we think to get that first encounter.
It's a reasonable thought. I when people say, like, if so this and if so that, then we should. Like, when there's we should have seen aliens by now. When that gets said to me, all I hear is, I want this to be true, so it should be true.
Yeah.
Which is, like, characteristic of humans.
Yeah.
I want, so it should. Or, like, the logic dictates, so it should. It's like our addiction to certainty or something like that. Like, I'm not going to deal with something that's not certain, but that's all only one hemisphere of the brain activity. Yeah. It's not encompassing the whole range of possibilities. They're explaining it to us.
Yeah.
Now that we know how many worlds there are and how many possibilities that there could be advanced civilizations, the question remains, why is the universe silent? Maybe we're about to find out soon as technology advances, or perhaps we've already been visited by some faraway civilization and just don't know it yet. There have been many unexplained UFO sightings recently, and some believe extraterrestrials are already here. Solid proof of that would put an end to this paradox. The bootstrap paradox is a paradox of time travel that questions how something that's taken from the future and placed in the past could ever come into existence in the first place. It's a common theme used by writers inspiring plotlines in many science fiction films, such as the Bill and Ted movies, Terminator, and Doctor Who. So let's look at one of the examples of this paradox. Imagine that you're a time traveler, but before you go on an excellent adventure, you go into a bookstore and buy a copy of Hamlet, written by Shakespeare. You then travel back in time to London during the Elizabethan era and give the book to Shakespeare. William S. then copies the book and claims it as his own work. Centuries go by, and during this time, Hamlet is printed and reproduced countless times until a copy of it ends up in the same bookstore that you bought it from. The question then becomes, who wrote Hamlet? This is another famous paradox, which involves you going back in time to take out your grandfather. By that we mean erasing his existence. Now, we know everyone here loves their grandparents, but this is only an example. Once again, you're a time traveler, and you pop back in time to do the deed and erase your grandfather's existence. You then return to present time. But the thing is, with your grandfather gone, your father wasn't born, and you now realize you never even existed. Everything about you has now been erased, including all your family, friends, all your possessions, and your history. So you wouldn't have been born in the first place. So it would be impossible to do this. Now, some scientists believe that if this were to happen, you would have now created alternate timeline or even entered a parallel universe. By the way, for those who missed our video on parallel universes, check out the link in the description. Another interesting variant to the grandfather paradox, going back in time to eliminate Hitler to stop World War II. This would have some interesting consequences. Let's say you have a shiny time machine, and you've got a plan to go back before things get out of control during the war and put things right. The problem now is that the action removes any reason to travel back in time, along with any knowledge that the reason to time travel back ever existed. Acting as a time-traveling executioner simply creates a paradox, and, along with the many worlds idea, traveling back in time might create a new timeline without Der Führer. But the old timeline would also still exist. You might even create a new timeline that's even worse. But what would happen if you sent something back through a wormhole? The late, great Joseph Polchinski is the famous theoretical physicist who wrote the book on string theory. But Polchinski also came up with a potentially paradoxical situation involving a billiard ball sent through a wormhole that travels back in time. In this scenario, the billiard ball is fired into a wormhole at such an angle, if it continues along the path, it will exit the wormhole in the past at the right angle to collide with its earlier self, thereby knocking it off course and preventing it from entering the wormhole in the first place. However, some physics students came up with solutions which avoid any inconsistencies by having the ball emerge from the future at a different angle than the one used to generate the paradox, and deliver its younger self a glancing blow instead of knocking it completely away from the wormhole. A blow which changes its trajectory in the right way, so that it will travel back in time with the angle required to deliver its younger self this glancing blow. Now here's something that will make you think about reality differently. The observer's paradox is something very strange indeed. And of all the bizarre facts of quantum theory, there are fewer stranger than Schrödinger's famous fable about a cat that's neither alive nor deceased. For the record, this is a thought experiment only, and no animals have ever been harmed. The paradox describes a cat that's locked inside of a windowless box, along with some radioactive material, a Geiger counter, a hammer, and a container of deadly poison. The radioactive material has a 50% chance to decay. If the Geiger counter records an emitted radioactive particle, it then triggers a hammer that smashes a vial of poison that will be fatal to the cat. However, you would not know if the cat was alive or deceased until you opened the box. And so until the box was opened, the cat would be both alive and deceased at the same time. How is this possible, you ask? This is because simply looking at matter actually changes the outcome of what happens to it. You can't know something is there unless you see it. Now, you're probably saying this whole thing is very strange, but consider another observer's paradox called the double slit experiment.
Before we get into the double slit, which I was kind of expecting on this, the other ones I'm a little surprised because they seem more theoretical than anything. I always love the talk of time travel, but I'm surprised at the title that these paradoxes will, keep scientists awake at night. Because a lot of it, it's like, it'd be different if you could actually go back in time and then test it out. But these are all theories. You wouldn't know until you actually did it. So I don't see why this would make anyone panic.
Well, then you'd go to do it and you'd be like, oh yeah, none of it's possible. It's interesting that we look at paradoxes as like a segment of reality. Like, we're in reality and we know what's going on, but these are paradoxes you can look at. Yeah. And pretending as if all of reality isn't a paradox.
Yeah. Oh, yeah. That'll mess you up.
The whole thing is a paradox.
Yeah.
It is.
Yeah.
And so, whatever. Learn that.
Yeah.
You know, hopefully this like opens the mind up to that. Wait, if paradox can exist at all, what else is a paradox? Eventually conclude it's all paradox.
Yeah.
And then the reality of what philosophy really is and the reality of what everything is becomes blaringly obvious, and things can be different.
Well, you can also have fun with it. Like, it might freak you out a little bit, but I'm sure not everyone's into this stuff, like maybe as much as us. But I know there's some people out there that are into it and they like it. And usually, if you're probably into this stuff, you're not probably bothered by it. If you're going out like looking to go understand paradoxes and see where paradoxes and
that's true.
Reality doesn't make.
I don't know who I'm talking to.
Doesn't make sense. Right? You know, but yeah, anyway.
Yeah. Yeah.
This is the most famous physics experiment of all time. Imagine a wall with 2 slits in it, and then throwing tennis balls at the wall. Some of them will bounce off the wall, but some of them will travel through the slits. If there is a wall behind the first one with slits, some of the tennis balls that made it through will hit it. Now, if you mark where the tennis balls hit the second wall, you should expect to see 2 strips of marks, roughly the same size as the slits. Sounds pretty straightforward. But in the double slit experiment, something awfully strange happens when you shine a light through the slits. Light isn't just a wave, it's also a particle called a photon. Now, if you shoot a single photon at the double slits, it forms an interference pattern on the back wall, as if it's interfering with itself. It's like the photon went through both slits at the same time. But this is where it gets stranger. Simply by looking at the double slit experiment, the behavior of the photons changes, as if the photons are alive and know you're watching them. We know this because if the experimenter tries to find out which slit the photon is going through, the interference pattern doesn't show up at all. The bottom line is that observing a photon can change events that have already happened. How is that possible? No one's figured it out yet. Maybe you might be the one to solve this puzzle.
Almost done, but I just want to be clear about that because maybe I'm misunderstanding it. But the gist of that last one seemed to be, depending on whether you're looking at photons or not, they behave differently. Yeah. And what are photons? Because that you could say the same thing about a cat. Yeah. Like if you're looking at the cat, it might look at you weird. If
I don't know. Is it something that's found within everything? I don't know.
Yeah, is a photon, maybe somebody in the comments, this would be your chance to speak up. Is a photon represent like matter at a base level? In which case, like if it's something around there, like it's their molecules that make up matter, then what that means is if you're looking at it or not, it behaves differently. Like human looking at it, I think you can even record it. No, if you're recording it, it behaves differently.
Well, it makes me think of like, well, what happens like with reality that we look at? Like, are we creating reality by observing it? Like when we look out farther and we see something for the first time, did we create it because we were able to gaze farther out into it? Is there nothing beyond that? There's actually nothing beyond it. We're actually creating reality.
What level are we? What if you found it? Yeah. Is there nothing behind it? Sort of like a video game refreshing.
Just so cool.
Yeah, like when you're looking at it, is it refreshing before our very eyes? Yeah. Is science made up as we peer closer? It's like the more answers come in, but there's a mystery beyond that point that we can see too. And I think it points out how much more possibly influencing and involved we are than we think we are. Yeah. Like we had that girl on recently that talked about plasma and everything being sort of like unified. And what if it's more of that than you think? Like your mind interpreting the world around you is like part of that soupy content that's being generated. You know,
maybe it's a warning too. Also, like be careful how far you look out. Be careful how far you look in. You may not want to see necessarily, or I don't know. Maybe it's not a warning, but I don't know. I was just thinking, like, you may not want to know. Like, if you could zoom into your hand farther and farther and farther, you may not want to know what you discover. Like, whole universes within yourself, within a cell, or whatever. Or beyond
in all directions. Infinity in all directions. Infinity inwards, infinity outwards, infinity sideways, in every direction.
One of the biggest paradoxes in physics is the black hole information paradox, a puzzle that results from the combination of quantum mechanics and general relativity. Calculations show that physical information could permanently disappear into a black hole, allowing physical states to devolve into the same state. But this is controversial because quantum mechanics states that information can never be destroyed. Let's say you burned 2 different letters written on paper. Putting them back together from ash would be nearly impossible, but not entirely. The small differences in smoke temperature and the amount of ash would still retain information about the 2 different letters. The problem with black holes is they suck things up and then, over a very, very long time, radiate what they've swallowed back out in the form of Hawking radiation. Unfortunately, unlike the smoke, temperature, and ash from burning a letter, Hawking radiation contains no information about what the black hole ate. This is because all Hawking radiation is the same, which implies that black holes destroy information about the universe. So, do evaporating black holes really destroy information, or does information escape as the black hole evaporates? A new generation of physicists say that information does indeed escape a black hole by their radiation, and they've identified an invisible surface that lies inside a black hole's event horizon called the quantum extremal surface. This surface appears to encode the amount of information that's radiated away from the black hole, evolving over the black hole's lifetime exactly as expected if information escapes. Apparently, something can escape a black hole. It's a problem not completely solved yet, and it's a work in progress. When we find out for sure, stay tuned here, and we'll let you know.
So that was as I always suspected it about black holes. What did the event quantum event? Just kidding. I don't know. I had trouble. I'm too stupid to
I just think like black holes are like wild when you think about like the power of a black hole. Like,
I don't. They're so far out of my reference. I don't like care about them.
Yeah,
you know what I mean. Like I'm like, okay, it's a black hole. Why do I need to know the ins and outs of it? Like I'm sure it's pertinent information.
Yeah, it's just curious. I'm curious about them, and I think it's fascinating that they go around the universe devouring solar systems, and like it's just like powerful. Then like what happens?
What was the paradox in that last one though? What was the
totally sure? I'm not totally sure.
Yeah, neither am I.
About many of the things in there. I was like, where's the paradox fall into this? Because a lot of it's just still theory, but.
I'm not claiming there wasn't a paradox claimed about the black one. I'm saying that's how much I didn't get it because it's an intelligent subject.
Yeah.
And it seems complicated, but I'm like, until I got to like deal with a black hole, I have a hard time caring about a black hole.
Maybe it has to do with the fact that it's like devouring everything, but at the same time it's spitting everything back out or something. Like, how can it be doing both at the same time? I don't know.
Isn't that like how your digestive system works?
Yeah, maybe it's the digestive system of the universe. It just like swallows everything out and then spits it out, and then it has to reanimate itself back into whatever it becomes zillions of years later. Who knows?
Yeah.
But fascinating, good video to watch. Enjoyed this Destiny video. Hopefully you guys liked our reaction on it. If you did, don't forget to hit the like, subscribe, share this with a friend, and everyone till next time, stay spiritual.